It is Play Monopoly Day. Have we played Monopoly? Do we know this game? You know the game, you like buy up stuff. Um, yeah. Thank you, Golly, for putting the link in there. Josh, you should grab the link and don't forget to watch it. Yeah, it's super long. It takes like 90 years. It's like a really good game for quarantine probably because you it can like literally play it for hours and hours and hours depending on how long. It's Break Friendship Day. Oh no, Kayla, did you lose a friend because of Monopoly? That's funny. I mean, not funny, but that's funny, weird. Your family has, oh my goodness. Yeah. So it's Play Monopoly Day. When Monopoly, fun fact is that when Monopoly became popular, it became popular in the 30s during the Great Depression. And in the Great Depression, obviously, money was really tight, and it didn't come with any of those little tokens like the thimble or the wheelbarrow or like the little things that you like move around the board as your tokens, your pieces. It didn't come. You just used what you had. So the so people would use like beads or like little like bracelet like I can't think of the word. Anyways, they would bring little things, and yeah. Anyways, so you had to provide your own. So then after the Great Depression, when they started like sending out the little pieces, they made these silver ones. Silver ones are the originals, except for this cat is one of the new ones. And then in 2017, they retired the thimble. They're no longer making the thimble. And so then they had a vote with all of these other gold ones. And people voted on which piece to get rid of out of the original set. And it was the thimble that didn't get enough votes to stay. And then they wanted to replace it with all these. Look at that cute penguin one. So cute. I never noticed that before. Anyway, I have the credit card one. I feel like a millionaire. Yes, there are so many different versions. There's like the Disney version. There's like so many different versions. Disney. There's like my parents have Oregon State Opoly. My parents went to Oregon State, the college, and so apparently there's one that's like specific to Oregon State. Instead of buying like Park Place, you can buy like the like football stadium or something. I don't know. Galilee uses the hat. Yes. So the question is, what shape would you use for a token to represent something special? So it could be one of these that are up here. Like, which one would you choose? Like, look at that T-Rex. How awesome is that as a piece? Or you can make up your own shape. So which one would you use? Would you use the hashtag, formerly known as the number sign? Would you use the camera? Would you use the cowboy hat? Oh, Galilee, the cowboy hat or the top hat? Would you use the sports car or the jet ski? The rabbit or the duck? Yes, for sure. Those are good. Like there's like a rooster. There's like a emoji, I guess. It's like a smiley face. Some of them are weird. I'm like, why would you vote for that? I would vote for the penguin or the rubber ducky. It's cute. I like this beach ball. I want it to be a volleyball. That's what I would choose. So which one would represent you? Oh, look, here's another. This is like the kissy face emoji. I don't know. The kissy face emoji. The hashtag, they're really trying to reach out to us. Look like an old school TV. I don't know. The TV one is what you would choose, David? Sounds like a plan. Yeah, these are pretty awesome. I don't know. I actually don't know which one won. I tried to do a lot of research on which one won. And by a lot, I mean, I looked for like 3 articles, so not a lot. But there was just a lot of articles about the fact that they were replacing the thimble, but not a lot of articles about what they replaced it with. So if anybody wants to find that out for us, that would be awesome. The golden rubber ducky is pretty awesome. I agree, Axel. Yeah, Amaris, you're like an original. You like the wheelbarrow. That's like your jam, huh? I love it. Cool. If you know Diana Lopez, it's her birthday over break, so you can wish her a happy early birthday if you are seeing her around. And then we're going to jump into it today. Any last questions? Any last questions? Galif, if you could drop that link one more time in the chat. Thank you, Galilee. Miss Matucci, let me double check my breakout rooms really fast. Yeah, it looks like she took them to her own room. No longer in my call.
Thank you.
No problem. Okay, Precalc. We're going to jump into it today. We have our agenda. We're going to do quick announcements, and then we have notes 16 and assignment 16. So pretty easy. I mean, I'm not going to say easy, but pretty like routine day. Nothing crazy today. So only one major announcement today, which is that I am not having office hours. I'm super duper sorry. I know that I didn't have office hours on Tuesday, and then I'm not having office hours today. However, I am setting up individual meetings, or I can meet with like your group of friends if you would like to talk about something. You guys did an amazing job on Tuesday's assignment, even though it was challenging. So I actually didn't get that many like, please help me text messages. So I am encouraging you, please send me a text message or an email if you would like some support today. I can be around, but I have the afternoon off, so I won't have office hours this afternoon. I am also supporting people tomorrow at some point. I've like set up meetings, so you can ask me for a meeting tomorrow. I'll also have a meeting on, or like I'm also available on Monday and Tuesday of next week. And then we can also just text message, whatever feels best for you. Okay. Are there any questions about my availability? Questions, thanks. Just keep sending me a chat. It just means I won't be available from 3:30 to 4 today. I will be on an airplane. But you didn't hear that from me. Actually, you can. I don't know. I'm recording it. It's about to be on YouTube. But anyways, I'll be very safe, I promise. Okay, great. Ale, don't tell on me. All right, so we're gonna jump into our notes. In order to do our notes, I want us to look at this problem first. Let's think back. We're thinking back to fractions. When we did multiplication and division, when we did multiplication this past week, we just did 1 times 3 and 2 times 7. Can you do the same thing for addition? Can you do 1 plus 3 is 4 on top and 2 plus 7 is 9 on bottom? Is the answer to this 4 9? No. Sadie says no, it's not. David says it's not. Okay, so team, what do I have to do before I can add these together? Lowest common multiple. You need the same denominators. Yes. Common denominator. Seeing lots of yes. Great. We need to find a common denominator for sure. What would be the common denominator between 2 and 7? Yes. 14. For sure. 14. So 14. So I would do 2 times 7. And then what do I have to do to the 1 to make it? If I change this to 14, what would the top be? 7. Yes. 7, 7. So 7 over 14 plus, this would be 2. So multiply 2 on top and 2 on bottom. So this would be 6 over 14. So 7 over 14 plus 6 over 14 would be 13 over 14, right? 13 over 14. So we have 7 14ths and 6 14ths, 13 over 14. So I'm glad that we're feeling like that's a good place. I want to start with a story. I have a mini story for you. I have 2 options. Number 1, I have previously recorded this story, and I think that it is really fun to watch because you can hear people responding to the story. I think it's really funny. Or I can tell you the story individually, or I can tell you the story right now, and you can respond to it in the chat, or you can come off mute and respond. Which do we prefer? Do we want to watch the video response where we can watch people, or do you want to hear the story live? In the chat says video. Great. Live. Oh no. video. Okay, there are 2 votes video, 1 vote live. 2 votes, 2 and 2. It's tied. I'm in between. Live, video. Oh my goodness. Okay, video is winning though. We have like 10 videos and like 6 lives. Okay, I'm gonna show you the video. And then if you need me to tell the story or like clarify something, or if the video is sucking, I will pause the video. So just let me know if the video is not working. So, but I preloaded it so you can check it out. Guys, here's the problem that we just did. It's on the board. I just went over it. And now I'm about to say, here we go.
When we
Oh no.
are,
Don't do this.
I actually have a mini story for you. Okay, so get in, ready? Story time. So my mom, I love her dearly, is best friends with our next door neighbor. Okay. My next door neighbor's name is Phyllis. Does anyone know that name?
I like that name, Phyllis. Oh, look at Phyllis over there.
Like
Having
this.
fun. Hi, Phyllis.
Phyllis, like this.
Hey, Phyllis.
And it's a female name. That's a girl name. So she's like they're so funny. They've been best friends for now 20, how long did we move in that house? 25 years, maybe?
Aww.
27, wait, how long? 25.
Long enough.
Long, right? They've been friends forever. And I love to, my dad loves to tell this story. He's always like, so one day when we moved in, we built our house. There was nothing there, right? And Phyllis moved into her house like shortly thereafter, and they're next door neighbors. But like the backyard is completely bare. All it is like some grass that came with the house, and then like literally in Colorado, like rocks. It's not even like gravel, it's like rocks around the outside, right? So my mom goes to Home Depot. She loves Home Depot. She said that if she wasn't a teacher, she would work at Home Depot. Really, it's her favorite store. So my mom goes to Home Depot and she's like, I want to buy a tree. She's from California. She loves trees. She wants to buy a tree. So she goes to she goes to Home Depot and she buys a tree and she brings it home and she plants it. She's like really excited about it. And then Phyllis comes over and Phyllis is like, oh my gosh, I love your tree, right? Like, I love it. I want one of my own. So what does Phyllis do?
Go buy her own tree.
She goes to Home Depot and she buys her own tree, right? But when she goes to Home Depot, she also brings home some flowers. So she now has now she has a tree and flowers. And my mom like peers over the backyard fence and is like, wait a second.
I like them flowers.
I like those flowers, right? So then she goes to my dad and she's like, honey, we have to buy some flowers. My dad's like, why? We just bought the tree. Like, do we have to buy the flowers? And my mom's like, yes, we have to buy them. Like, I want them, right? So she goes and she buys the flowers. My mom buys the flowers. But like also when she's at Home Depot, she's like, she's ridiculous. So she buys more things, right? So she bought, I think like a wheelbarrow or something.
Oh.
So she buys a wheelbarrow. And then Phyllis, what does Phyllis do? She's like, wait, I need a wheelbarrow. Instead of borrowing my mom's, she goes to Home Depot and buys her own, right? So eventually like it pauses and they're all the same. But over the course of like 25 years, what do you think happened to their backyards?
They look the same.
Their backyards look exact, kind of a rose garden, yeah, actually. They look like pretty much exactly the same. Because every time my mom gets something, Phyllis gets something. And every time Phyllis gets something, my mom gets something. And so their backyards look totally the same. It's like ridiculous. Their front yards, different, right? Their front yards are like, I don't know why. Their front yards, I guess, apparently don't matter. But their backyards look exactly the same. I don't know. That is my favorite story to talk about the fractions that we're gonna deal with today. Because the backyards, the denominators, have to stay the same. So if one fraction has one thing, that other fraction also needs that one thing. And if the other fraction has something that this fraction doesn't have, we have to make them have the same fractions. Does that make sense?
Yeah.
Yes.
Okay, let's do it. So we're gonna use.
Okay. Do you like my story about Phyllis? Yes. Yes. Best friend things. You thought I was gonna say their tree and flowers died? No, their tree and flowers did not die. My mom has an amazing garden. Yes. How large is the backyard? Well, my parents still live there. How large is the backyard? I can actually show you tomorrow because I'm gonna be there tomorrow. So if you come to office hours, you can see it. It's big. It's really big. It's like very big. It's in Colorado. Land is very cheap, and it's not like LA where like everywhere has like, you know, apartment next to apartment next to apartment. Like it's not like that. There's like lots of land in between. I am also wishing I was at school. The reason I wanted to show you that video is because like, guys, we're going to get that back there eventually, right? We're going to all sit in the same room eventually. We just have to be patient. I know I'm missing so much. Everyone laughing together. Guys, this is why I'm like, please come off mute. Please come off mute and talk to me. I'm just talking into the void, just looking at a bunch of boxes with letters and some good photos. Thank you for those people who put photos. Okay, so anyways, this is my favorite story because number one, it's hilarious to me. And number two, because my mom and Phyllis are really going to help us on our math today because they're going to remind us about common denominators. So we're going to jump into our notes. I know it's like, John told me that it was an amazing, John, who was in the background, you could like hear him. And John Franco and John said that this was like it's a funny story, a great story, and a boofy transition. Like my transition was like not so great. So anyways, here we go. We're going to transition to our notes together. And if you are, I did that wrong. Please hold. Let me do a new share really fast. New share. Turn off my computer sound so you don't hear all that dinging, people trying to get in here. All right. So today we are going to think about my mom and Phyllis a lot. Another funny part of that story is one time, then my mom came to visit and all of my students were like, oh my gosh, are you Miss Mac's mom? And then she was like, yes. And they were like, can you tell Phyllis we said hi? And I was like, my mom looked at me and was like, how do they know who Phyllis is? That's so weird. And I was like, don't worry about it, Mom. It's fine. No. Okay, so there is the first situation where the denominators are already the same, right? So where the denominators are already the same, super duper easy. We just subtract straight across. If we have 5/12 minus 1/12, then we would have 4/12, and then we would reduce that to 1/3. Right? Same thing when we're adding, we have 7/15 plus 3/15 is 10/15 all together. We reduce that, that's going to be 2/3. Right? 2/3. So we can reduce it super duper easy. We're going to do the exact same thing when we have something like this, right? Exact same thing when we have something like this. As long as the denominators are the same, and here we see x squared minus 4 and x squared minus 4, we are going to say, okay, I know the denominator is going to be x squared minus 4. And then we have the 2x plus 3, and we're subtracting the whole x plus 1. So we're really subtracting this entire thing here. So the subtraction is going to go on the x, and the subtraction is going to go on the positive 1. So I'm going to go ahead and write here first 2x plus 3. And then I'm going to have minus x and minus 1. Minus 1 at the end there. So I'm going to combine like terms. I have 2x minus x would be just regular x. And I have 3 minus 1 would be plus 2. And it's over x squared minus 4. Over x squared minus 4. So first step was to like put them together, put them into one fraction. My second step was to sort of simplify that. And my third step, thank you, Walter, in the chat. My third step is to see if I can reduce anything. So in order to reduce, I need to turn the denominator into its factored form to see if there's anything I can cancel. So the x plus 2 is staying, but I notice this is the difference of squares. So it's a square and a square number 4. So this is x plus 2, x minus 2. Like that. And then I'm gonna see, is there anything I can cancel? Is there anything I can cancel? Like we were doing on Tuesday. Yeah, the x plus 2s. So x plus 2 and x plus 2 will cancel. They divide to 1. When I say cancel, what I really mean is divide to 1. So x plus 2 divided by x plus 2 equals 1. Like they are the same. So it equals 1. So it'd be 1 over x minus 2. 1 over x minus 2 will be the first part of our answer. And then what are our excluded values? What is x not allowed to be based on these two denominators, two pieces of the denominator? -2 and +2. Yeah, so -2 coming from here, +2 coming from here. From -2 and +2. So this is my answer there. So that is my final step, is to write them, to write out the leftovers and then to write out the excluded values here. Okay, show me in the chat where are you at on this problem. How do you feel? Are you a 0? I don't get this at all the way up to a 5. I totally get this. I'm ready to move on. A 3, I have a question. Okay. Okay. Thank you for the private messages. Thank you for the everybody messages. David Lopez is a 6. He's ready to go. Jonathan, do you have a question? Anybody have a question for me? Right, so if I'm thinking about this in steps, I would say I'm going to combine them. I'm going to combine the fractions because they have the same denominator. I'm going to simplify the numerator. I'm going to simplify the numerator. Step 3 is to factor and cancel. Right? And then step 4 is to rewrite. Oh, amazing, Jonathan. Sounds like a plan. Cool. All right, let's try the next one. So in the next situation, it says that one denominator must be multiplied by at least one factor to make them the same. So if I have this here, I have 5 and 15 as my denominator. What could I do in order to multiply them? Or what do I have to multiply in order to make them common denominators? 3, yes. I want to multiply this one times 3. If I do that on top, I got to do it on bottom. I also have to do it on top. So I have 9 over 15 minus 7 over 15 is 2 over 15. All right. So 2 over 15, I can't reduce it. So that's my answer. So we're going to do something similar here when we see that they have unlike denominators, right? They're not common denominators. So first thing I'm going to do is factor this part here, this denominator. I want to factor that to see if they already have anything in common. So for example, in this one, I knew that 15 was already 3 and 5. They already had the 5 in common. So I didn't need to multiply times the 5. I just need to multiply times the 3, right? So I'm going to do something similar here. If I can break this down, what does x squared minus 4 break down into? Someone come off mute. I miss you.
X plus 2 and x minus 2.
Yes, thank you, Galilee. Someone join Galilee. Galilee comes off mute pretty often. So help me out, y'all. Okay, so instead of like rewriting this over and over and over again, what I do when I have it, I have like the black part written here, and then I'm gonna like just scratch out this part basically, and now this is my denominator. So this is my new denominator. They already have, and they both have an x plus 2. So this is where my mom and Phyllis come in. Are you ready? This is my mom's fraction, and this is Phyllis's fraction, right? You can see my cursor, right? Like when I'm doing all this circling on my screen, you can see it.
Yes.
Yeah. Oh, great. Thank you for coming off mute. Appreciate you. Okay, so this is my mom's fraction, and this is Phyllis's fraction. So in my mom's backyard, she has an x plus 2 and an x minus 2. But Phyllis only has an x plus 2. So what does Phyllis want?
X
What
minus
is,
2.
yes, Phyllis is going to go to Home Depot and she's going to buy herself an x minus 2. Right? And remember, if we do it on the bottom, we have to do it on the top. Like this. So now their backyards are exactly the same, right? Their backyards are exactly the same. So we can go ahead and combine them. So I know on the bottom, their backyard is going to be x plus 2, x minus 2. And I know on the top, I'm going to have this first part here. So this part here is x squared plus 6x. And then remember that this is minus 2, right? Minus 2 times x would be negative 2x. And negative 2 times negative 2 would be positive 4. Like that. So I made my denominators the same. That was my first step, was making my denominators the same. My second step is to write it down, write it down as one fraction. And now my third step is going to be to combine or simplify the numerator. So x squared, I have 6x and negative 2x is positive 4x plus 4 all over x plus 2 times x minus 2. Can I factor, right? Can I factor the top portion? Like, can I break down the numerator into 2 factors? Are there any 2 numbers that multiply to get 4 and add to get 4? Yeah, 2 and 2, right? X plus 2, x plus 2, like that. And then my denominator is still x plus 2, x minus 2. So my fourth step was factoring. Now, is there anything I can cancel? Yeah, we can cancel the x plus 2. So I can cancel x plus 2 and x plus 2. And then I have x plus 2 over x, x minus 2. And x is not allowed to be from here, negative 2, from here, positive 2. So it's not allowed to be. What questions do we have? Anything? Negative? Okay, how do we feel about this problem? Are we still feeling like 4s and 5s? Or are we starting to feel a little like, ooh, I don't know what happened? You can private message or send to everybody. Cool. Some 4s and 5s, the 4.5, some 4s. All right. Okay. Can I label the order I did it in? Yeah, like the steps? Yes, I can. Let me, yeah. So the first thing that I did was up here, I made common denominators. So I got a common denominator to start. The second thing that I did was I simplified the numerator. Well, no, I combined, sorry. Combined the 2 fractions together. The third step was to simplify the numerator. The fourth step was to factor and also cancel. Factor and cancel. And then my fifth step was to write the leftovers or write the answer. Thank you for reminding me to write the steps down. I was meaning to do that, so I appreciate that. I'm going to leave this one on the board. So those of you who are still copying can, and then copy down this question here. Awesome. Thank you, Caitlin. All right. You're feeling 3.14159. You're feeling pi. I'm feeling pi too. I feel like we should have some pi. Okay. Let's try one more, and we're going to use my mom and Phyllis again so we can think about it. So I want to look at this one. This is where the denominators are the same, and I can't just like multiply one of the numbers to get the other number. So 12 times a fraction gives me 15, and I would need to divide to get to 12. So something that I can do is I can say, okay, 12 is 3 and 4, and 15 is 3 and 5. So if you think about this as my mom and Phyllis, both my mom and Phyllis already have a 3. They don't need another 3, right? They both have a 3. My mom has a 4, so Phyllis is going to go out to the store and get a 4. And Phyllis has a 5, so my mom is going to pick up a 5 at the store. So now my mom and Phyllis are both they're all gonna have a 3, a 4, and a 5, right? 3, a 4, and a 5. So 3 times 4 is 12, times 5 would be 60. So we have 60. We have 5 times 5 is 25, plus 4 times 4 is 16, and 3 times 5 is 15, times 4 is 60. Same denominator, right? So for some of you, I'm sure you saw 12 and 15 and you were like, oh, what's the least common multiple that I can get there? Oh, it's 60. And you knew I had to multiply times 5 and times 4. But for me, that's not always like the easiest way to do it. So sometimes I break it down to see what my mom and Phyllis already have. And then I can find it. Wow, I'm so pumped. The chat is like blowing up with private chats like, whoa. Yes, great. I'm so glad. Kind of a nebulous process. My mom and Phyllis helping us out. So, okay, do we feel good about that? Yes. Yes, yes. I love that some people love the private chat and some people love the everyone chat. It's the best. All right, here we go. So for this one, I'm gonna factor them. My mom and Phyllis are so helpful. I'm gonna start by factoring, right? So my first step is gonna be factoring. So what can I factor? How can I factor the denominator of this? It's not a trinomial, so it's not gonna be 2 parentheses, but I do see that they have something in common. So what can I take out? Yes, 2x. Thank you, Brandon and Galilee, x plus 1. So I can, and Kayla, thank you. I have the 2x is coming out. I can divide out 2x from both, and then x plus 1 will be left over. So my mom has a 2x and an x plus 1. And Phyllis over here, ooh, big spender, has a trinomial, has x squared minus 2x plus 3. So she is going to break down into a trinomial if we can. What numbers multiply to get -3 and add to get -2? -3 and positive 1, yes. X minus 3, x plus 1, like that. What do my mom and Phyllis have in common? What do they both have already?
X plus 1.
Yeah, x plus 1. I think that was Diana. Thank you, Diana. X plus 1, they already have an x plus 1 in common, right? They already have that in common. So they do not need to go to the store and get another one. That would just make it really a big obnoxious problem. So my mom has a 2x. My mom has a 2x, but Phyllis does not have a 2x. So Phyllis is going to go to the store and get a 2x. Right? My mom has, so now they have a 2x in common. Do they have the same backyards yet?
No, they need to get the x minus.
Yeah, my mom needs to go to the store and get an x minus 3 for sure. Thank you so much, Mia. right? We need to go to the store and get an x minus 3. Now, are their backyards the same? Yes. Yes, now they are. Okay, so now their backyards are the same. So their backyards are a 2x, an x plus 1, and an x minus 3. There's no order. You need to write it in MBD. The only thing is that it normally, like if it's just 2x, there's no addition or subtraction. That normally goes first, but you could write it in any order that you want. It's your mathematical prerogative. Now I need to write down the numerator. Right? Remember that step, the next step was to combine them together. So my next step is to combine. So I'm going to deal with, the colors are getting out of control here. Blue. I'm going to deal with this part first. I need to distribute the 3x times the x and the 3x times the negative 3. So I'm going to get 3x squared and negative 9x. That is my blue portion here. Right. Then I need to combine the negative, the x plus 2, and the 2x. So for me, I think it would be easier to take to take this guy. Wow, do you see this? I'm like moving it. Funny. Okay, come on. There we go. To move it over here like this, right? But that's going to make it real complicated in there. So what I'm going to do is I'm going to rewrite it. I'm going to write negative 2x times x plus 2. So all I've done is taken the negative, the 2x, and this, and just rewritten it right here. The 2x said not today. Yes, the 2x said not today. So now I'm going to go ahead and distribute in right here like that. So I have negative 2x squared minus 4x. I have 3x squared minus 9x over the common denominator, which I'm not going to write. I'm just going to write least common denominator. So I don't want to write it over and over again. Okay, now I need to simplify my numerator. You can simplify kind of whenever you want, but I'm for sure going to simplify it here. Sticky note, blank. Cool. So I'm going to simplify it here. So I have 2x or 3x squared minus 2x squared would just give me positive x squared. And then 9x and negative 4x would give me negative 13x, like that. And then that is still over my least common denominator. Can I factor anything out of the x squared minus 13x? X, yes, I can take an x out. So I have x and I have x minus 13. That is my numerator. And now this time I'm going to write my whole denominator. So I need to go back and find it. 2x times x plus 1 times x minus 3. Like so. Is there anything that can cancel? This is 2 times x, just for those keeping track at home. So that's technically 2 is its own thing, x is its own thing, x plus 1 and x minus 3. Yeah, you can cancel an x. Yes, you can cancel this x here. So you would have x minus 13 over 2 times x plus 1 times x minus 3. Wow. We have x equal, or x cannot equal. We have the 0 from here that we canceled out. We have the negative 1 from here. And we have the positive 3 from here. So there are 3 things that x is not allowed to be. And that, my friends, is how my mom and Phyllis help us to do math. What questions? I'm sure there are some questions. What questions do we have about this one here? Anything? Anything? Without them, how would I explain this? What a great question. I did try to teach it a few times without using my mom and Phyllis. It was a hot mess disaster. People did not understand. Yes, the bottom is 2 times x plus 1 times x minus 3. Yes, Ellie. Why did I put the x minus 3 with the 3x? Oh, on top. Oh, wow, so many questions. I love all these questions. Okay, why did I put the x minus 3 with the 3x up here? Is because this one over here already had the green and the yellow, but this one did not have a green. So I needed to multiply. So like my mom was jealous. She only had a purple and a yellow, and so she needed a green. And so since I did the green down here, I also have to do the green on the top. Yeah, for sure. Okay, great question. Let me make sure I'm answering them. Brandon, amazing question. What if all the numbers canceled out? If all the numbers canceled out, it would be equal to 1. There is one problem on your homework that is like that. If everything cancels, it equals 1, because like if you have 10 over 10, they cancel, but 10 divided by 10 equals 1. Right? So when something cancels, it's really just multiplying to be equal to 1. We don't care about 1 anymore. Great question. My mom and Phyllis is the only way. It's true. So when you can take out an x from both, you still need to include 0 as an excluded answer. Yes. So when we did this step and we canceled the x's here, right? When we canceled the x's here, we still have to have 0 as an excluded value, because if we put 0 into this equation up here at the top, it would make a 0. So like if you put 0 right here, you would have 2 times 0 squared plus 2 times 0. That would equal 0, and you'd have divide by 0, and that is a undefined value. So if you cancel, this is all to say, if you cancel the x's, then you still have to have 0 here. Yes, you might have forgotten some on Tuesday. I do need to make you an answer key for Tuesday, so stay tuned. Gardens are intense. If the 2x would not have been canceled, would you set it equal to 0? Yeah, so if the 2x had not been canceled, it would have been 2x cannot be equal to 0. Divide by 2, x can still not be equal to 0. So whether it's x or 2x, right, both of them are going to give you that excluded value of 0. Amazing questions, my friends. Okay. I recognize that we're 2 minutes over, and I went 5 minutes over last time, so I'm very sorry, but I really appreciate you listening to my story. I do have another problem on the notes. If you want to watch it on the video, you're more than welcome to watch it on the video. The video is attached in your assignment as well as in the notes. If you would like to stay on, I will do that last problem with you, but I'm not going to keep all of you. So if you are feeling good, you can jump onto the assignment today. There are 7 questions for part 1 and 4 questions for part 2. So 11 total questions. It shouldn't take too long, but if it is taking you longer than an hour, please let me know. I don't want you to work more than an hour. Other than that, I hope you have an amazing weekend, and I hope that your break is solid. I don't think that we'll have another official class. Maybe Tuesday, might have office hours, but no official class until after break. So I will see you in December, I guess, or end of November. But happy Thanksgiving. Have a great time. Bye, guys. You can sign off if you would like. I'm going to stick around and do that last example if you want. Bye. Happy Thanksgiving. Bye, Fatima. Bye. Bye, Kaylin. Bye, Miriam. Bye, Diana. Feel better. Bye, Kayla. Bye. Adios, adios. Bye, Kira. Bye, Gally. Bye, Axel. Happy Thanksgiving, Gally. Awesome. Okay, my 10 of you who are still here, or 9 of you, however many, 9 of us, do we want to do the other one? Do you want to do this one? Yes, yes. Okay, let's do this one. Go ahead and write it down. So I know David and Mia are with me. Can you just send me a yes or give me a thumbs up if you are sticking around? So I know who I'm talking to. Awesome, Marceli. Glad to have you here. Cool, Giselle. Glad to have you. All right. Okay, so for this one, the first thing I need to do is get my mom and Phyllis to have the same backyard. So in order to have the same backyards, we need to know what each of them has. So how could I factor this one? What could I take out? You're welcome to come off mute if you
An
want.
X.
An X, yeah, thanks, Araceli. An X, and then what will be left over?
X minus 7.
X minus 7. Perfect. So we turned x squared minus 7 into x times x minus 7. How could we factor the other one? How could we factor 2x?
You divide by
minus 4?
2.
Divide by 2, for sure. So this one we're dividing by 2, and we would have left x minus 7. Right, so now this one turned into that one there. Okay, what do they have in common? What do they have in common here?
The x minus.
Yeah, the x minus 7. So both of them already have an x minus 7. They don't need to go to the store to get anything else. So my mom has an x. Does Phyllis have an x by itself?
No.
No, it doesn't, right? So Phyllis is gonna want to go to the store and she's gonna want to get an x. And she gets an x on the bottom, she also has to put it on top. Like that. This is the part where I would say, like, okay, we can put this x over here like that, because it's going to be technically negative x times this, negative x times that. So that's my thought. We'll put the x over there. All right. And then, so now my mom has an x, Phyllis has an x, my mom has x minus 7, Phyllis has x minus 7. Phyllis has a 2 though, so my mom is jealous because Phyllis has a 2. So I'm going to need to multiply the 2 on this side as well, which means I also need to do it up here. Like that. Do my mom and Phyllis now have the same backyard?
Yes.
Yeah, they have the same backyard. So now they're happy. And my dad's happy because he doesn't have to spend any more money at Home Depot. Although my mom makes her own money, so she's a strong, independent woman. All right, so our denominator is 2x times x minus 7, like that. What does the red numerator turn into?
2x minus 6.
2x minus 6, perfect. 2x minus 6, so 2 times x, 2x, 2 times negative 3, negative 6. All right, and then the green numerator is negative x times 4. So negative x times 4 would be negative 4x. And negative x times negative x would be positive x squared, like that. Okay, we combined them. So step 1 was to factor. And step 2 is to combine. Right, so let's see if I can put these in another color. Step 1 was to factor. Step 2 was to combine them into one fraction. Step 3 is going to be to simplify. Step 3 is to simplify. So I can put x squared I'm gonna have the x squared. I have 2x and negative 4x is gonna make negative 2x and the minus 6 at the end. And then I have 2x, x minus 7. That's my denominator. All right, I'm going to try to factor and cancel if I can. Is there anything that multiplies to get negative 6 and adds to get negative 2?
No.
No, I don't think so, right? Because 6 would be 1 and 6. That's not going to work. Or 2 and 3. And that's not going to work either. So this factoring doesn't work. So there's nothing we can do here. And we just leave it like this with our answer. We just need to write our excluded values. What is x not allowed to be?
0 and 7.
0 and 7. Yeah, so 0 from here and 7 from there. Yes. Perfect. How are we feeling now that we've done that one?
Great.
Great. You're feeling better, Mia?
Yes.
7 out of 10. I mean, no, 7 out of 5.
You're 7 out of 5. You're 7 out of 10. I'd be like, oh, 7 out of 10. That's pretty good. But 7 out of 5, that's way better. I'm glad. Giselle's feeling good too. Awesome, guys. Okay. So on the homework, whoa, this thing just flies around sometimes. On the homework, you're gonna have, let me wait for it to catch up. You have 8 problems. You're gonna do 7, so you can skip 1. And then you have all the answers over here. So you can make sure that you're getting them right, kind of thing. And then for part 2, it's error analysis. So you're choosing 4, there's 6 of them, you're choosing 4 of them, and you're gonna find the mistake and answer the question. So like, what was the mistake was made? What should they have done? So for example, in this one, I see that there's a negative here and a negative 9. And then when they combined it, they just wrote negative 9. They should have written positive 9 because negative times a negative would be a positive. This should be positive 9 times this thing. So you're gonna sort of like walk through. It might be easiest, to be honest, it might be easiest to just try to solve this on your paper here. Like try to solve it separately on your paper and then look at their steps and see where yours is different from theirs. So you might try that. That helps me when I'm doing your analysis. All right, team. That is pretty much it. I'm happy to answer any questions that you have. But other than that, you're free to go. Thanks for sticking around for that last question.